So my name is Robert Joja, and I am the product manager for alternative technologies in the engine mobile market. I am responsible for the development of filtration and separation technologies for fuel cells and hydrogen combustion engines. Next slide. In today's meeting, we are going to be discussing the market changes that are happening in the transportation industry, the filtration challenges and solutions for PEM fuel cells, and Andreas will cover the thermal management side of the fuel cell systems. Next slide, please. So first, let's look at the filtration challenges and solutions for PEM fuel cells. Next slide. So we can see that the world is changing and there is a clear shift from fossil fuels towards renewable solutions. There are several climate targets that are pushing us to reduce the carbon emissions so we can reach carbon neutrality by 2050. One of the pillars that we see towards climate neutrality is hydrogen, and this has a major impact on the energy, industrial, and transportation sector. In the transportation sector, there are several technologies that can support this shift. The battery electric vehicle is already available in the market, and it has the highest efficiency. And for certain applications, this is the best solution. The fuel cell electric vehicle, this can be an optimal solution for long-haul heavy-duty application due to its high power density, similar refueling time as diesel, and the long range. The hydrogen combustion engine can also be a very attractive solution since it relies on the well-established internal combustion engine and some required modifications for the hydrogen adaptation. So these technologies will be complementary to each other in this new market, and the appropriate one needs to be selected based on the application needs. Next slide, please, Andreas. So at Parker, we have created a product visual selector for the hydrogen applications. As you can see, we are working on products and solutions to support our customers through the whole hydrogen economy. Here today, we are focusing on the mobile market and where we have solutions for fuel cells and hydrogen combustion engines. Next slide, please. Today, we are focusing on the fuel cell technology. So for the transportation market, the proton exchange membrane fuel cell is the front runner. The distinguishing features are lower operating temperature and pressure ranges, high power density, and quick startup time. The fuel cell systems are composed of multiple fuel cells which are connected in series. Here you can see one fuel cell. Each fuel cell contains of three primary components. There are two electrodes, the anode and the cathode, and the proton exchange membrane in the middle as a conductive electrolyte. Each electrode is composed of a porous high surface area material, which is called the gas diffusion layer. And this is impregnated with an electrocatalyst, which is typically platinum or a platinum alloy. The chemical reaction on both the anode and the cathode side happens at the catalytic surface. So the hydrogen separates into protons and electrons, and the protons cross through the membrane, and the electrons travel along an external load circuit, and thus it is creating the current output. On the cathode side, similarly, at the catalyst, the oxygen will react with the proton and electrons and will form water molecules and residual heat. For the optimal chemical reaction on both sides, the catalytic layer surface needs to be free of impurities. Certain gases can poison this catalyst and can lead to power losses due to the reduction of the electrochemically available surface area. The membrane in the middle needs to conduct the hydrogen protons, but not the electrons, and must not allow either of the gas to pass to the other side. For optimal proton transfer, the membrane needs to be humid. For us to ensure the lifetime and the performance of the fuel cell system, a high level of filtration is required. If you go to the next slide, please. Here you can see the product that Parker is developing from filtration side for the fuel cell applications. If you look on the top side, you can see on the cathode side, the air side, we need to make sure that the air is clean and that is conditioned. stack. So due to the highly uncertain pollution of the ambient air, a cathode air filter is required to remove particles and absorb the gases. The humidifier is needed to humidify the clean air before it goes to the stack. And the water separator is needed to remove excess water so we can protect the humidifier or the compressor. On the anode side, at the bottom, we have a hydrogen filter to remove any particles coming from the refueling process, and we have a water separator so that the water is not recirculated in the system. On the thermal management side, we are developing an ion exchange filter and a coolant particle filter. Next slide, please. So the stack is very sensitive, as I mentioned, to different gases and contaminants, and these will be removed by the cathode air filter. The main function of the filter is to absorb these gases, such as nitrogen oxides, sulfur dioxide, ammonia, toluene, and others. These gases can poison the catalytic surface and can reduce the performance of the fuel cell. This poisoning can be reversible or irreversible depending on the different gases. The gas absorption performance is impacted by several parameters, such as the ambient air condition, environmental conditions, driving cycles. So the filter configuration and design needs to be optimized based on the customer and application needs. Our cathode air filters also have a very high particle efficiency and dust holding capacity. As well, they are designed for a low pressure drop. Next slide, please. We have a family of cathode air filters which are designed for different flow ranges. So depending on the application and the gas absorption requirements, we can select the appropriate filter size and the element configuration to achieve the overall best performance. When we are talking about estimating the life of a filter in real-life working condition, this is more complicated since the gas absorption performance will change based on the gas inlet concentration and will behave differently with a mixture of gases. Next slide, please. The second product that we are working on is the humidifier. The purpose of the humidifier is to humidify the membrane in the fuel cell for optimal proton transfer from the anode to the cathode side. For our humidifiers, we are using hollow fiber technology. We are developing our own hollow fibers in-house. This way we can control the performance of the fibers, starting with the chemistry and the monomer selection, all the way to the manufacturing and quality control. The main function is, of course, the humidity transfer of the fiber. And here we are working together with the Fraunhofer Institute to optimize the structure of the single fiber and to improve the flow through the assembly for reduced pressure drop and optimal flow distribution. The other critical targets of a humidifier are, of course, durability and reliability. The humidifier performance throughout the lifetime will be impacted by several environmental and work cycles factors, such as temperature, pressure, humidity levels, and air quality. We also see in the market now an increase in running temperature targets. So the fiber chemistry, the potting materials, the seals, and housing materials all need to be carefully selected and developed to fulfill the requirements. Next slide, please. The third product is the water separator. So the water separator is required on both the cathode and the anode side. The fuel cell generates a significant amount of water throughout the function, and this needs to be removed from the system. On the cathode side, we need to protect the compressor. And on the anode side, we need to make sure that this water is not recirculated with the hydrogen. The water separators that we have a very high efficiency performance and have a very low pressure drop optimization. The technology utilized here has been in production for a long time at Parker. We are developing also an automatic drain system for these products. We need to make sure that the water is released in a controlled manner. And this is especially important on the anode side because we don't want to have any hydrogen which is released uncontrolled. Next slide, please. On the anode side, we are also investigating the potential need of a hydrogen filter. Currently, the hydrogen available at the tank stations is clean, and the need of a filter is very low. However, due to the ramp up which we need in the hydrogen production, a filter on a vehicle might be required. We have developed a hydrogen filter that can remove particles and liquids from the hydrogen, This is targeted currently for the low pressure side of the system. It is utilizing hydrogen-compatible seals and housing materials. In parallel, we are also investigating at the development of a particle mesh filter for the high-pressure applications at 350 and 700 bars. Next slide, please. On the thermal management side of the fuel cell, we are working on an ion exchange filter and also on a coolant particle filter. So the ion exchange filter function is to reduce the conductivity of the coolant and to protect the stack from electric short circuits and power losses. The fuel cell system architecture, coolant degradation, the components and materials, and different working conditions will greatly impact the lifetime of the filter. For our filters here, we have a specific resin which is tailored for fuel cell applications, and this will increase the service interval of the element. The coolant particle filter is a high efficiency, no conductive filter. So the target here is we want to make sure that we are not increasing the conductivity in the system with the utilization of this filter. We have a wide range of filters with different micron ratings, and we can select the optimal solution based on the customer requirements. So as you can see, we have a wide range of filtration products to support our customers for their fuel cell applications. Andreas will now present our additional solutions for the cooling side regarding thermal management.
Yes, thank you very much. So my name is Andreas Lignowski. I'm the division market manager from Cylinder Accumulator and Cooler division. I work now more than 40 years in this fluid technology and components and commissioning. My focus today is electrification, hydrogen, and power generation. When it comes to this coolant circle, we see that we have there different cooling circle. There's one where we go through this high temperature, then we go to the separate segment on the right side. So there are a lot of coolant fluids available, could be different circle isolated from each other. And when you see here on this slide, there are a lot of components, what Robert explained. And we added to this the cooler, the air blast cooler, what's take care that the heat come out of the system and support the coolant with the heat transfer to the ambient. The other product we have here, it's a tank system. It's a small tank system, not a large tank system, but it is a Parker patented crimped piston, what we use for hydrogen storage. So when we talk about thermal management, the first thing what we need is have a highly efficient heat transfer and a large amount of air increase the power density in narrow temperature ranges. That's mean when you go on a mobile application, you have a lot of heat to disappear, and this have to be on a very small space. So what we did, we developed a special matrix, and in the matrix, a special turbulator that transport the heat from the coolant to the heat plate and from the heat plate to the air fins. And we see that there is a very big need on efficiency and density to reduce the size of the cooler. When you have the cooler on the top of a container or inside a vehicle, space is every time a problem. So this is what we did. We optimized the heat transfer in the turbulator to the air fins. And this gives us, when you see the picture here, a very good distributed heat transfer to the air fins. And this helps us to have a high efficient system. And then we have on the mobile application more than one coolant. It could be that you have the oil, you have the fuel cell, you have the electric motor with the motors, the inverters, the charger, maybe the batteries. So what we did, we developed a matrix where we can modular think and use different coolants in the same matrix in separated channel. And this reduced the design and installation work. This is high efficient. It reduced the space claim and the power consumption. From the specification point, we go from 1 kilowatt to 400 kilowatt. We can clean the segment for the fuel cell to a low conductivity. We can go in our modular system with 12 volt, 24 volt, or with 800 volt DC power for the air fin or the air fan motors. When we go to the industrial side of a thermal management system, then we see all this dry cooler on the roof of the thing. And we think that could be better when we use the same modular system for the mobile, for the industrial. So when we compare this together, we see that our power, it's so high that we have a lower space claim with the combination of high efficient matrix and high efficient fan systems. And this reduced the design and installation work. It is give you the option to use this cooler inside the container. From the specification, this kind of cooler starting from 50 kilowatt up to 400 kilowatt. Again, the matrix could be cleaned on a low conductivity. We have multi-variances on fan drives. We can go with our mobile motor on 800 volt DC battery power. We can use industrial motors in different frequencies. We can adjust in the modular system the fan design to have a low noise level, and the modular system help you to make maybe a redundant system so that you have one cooler, maybe two cooler, maybe three cooler in a parallel or serial architecture to make the best architecture for your coolant needs. And then we come to this small piece of a small tank. So what Parker developed is a patented crimped bottle. So we come from the technology of piston accumulator, where we do it now for ages, 20 years old, technology approved. But what we did now, we improve it for hydrogen. So we look through the sealing system, we involved the technical department to have an embrittlement check of our material. And now we come with a good solution on a single bottle, maybe on a bundle of the same bottles together in a kind of rack. We can integrate it in the end caps, the valves, to reduce the risk and the cost. And from the specification to have a sample, you see the bore size is 150. The length we can build, it's from maybe 1.5 meter, from a half meter up to 2 meter. The pressure range is fixed on 350. And when we see what gives you a weight of 100 kilogram, it's a 2 meter long storage tank. And you can use it stationary or you can use it in a mobile application to fit it in the space of your vehicle. So I hope it was not too fast. I like to try to come in the time slot we was expected to do.
Thank you everybody for joining our workshop and our breakout session.
Thank you very much. Every time welcome.
Thank you.